starting to kick in with some of y'all that hasn't already. It should be kicking in kind of soon. This is the rest of the semester, y'all. This is it. Time flies when you're having fun. We are finishing up our third week, and we have 5 more weeks to go. After next week, the week of July 4th, we do not have classes. The hub will be, like the tutoring part will be open some. I'll send you the hours of that. But we do not have classes the week of July 4th. So we'll have next week, and then we'll have 4 weeks when we come back. And that last week of class, I'm crossing my fingers that we'll spend a day of reviewing for the exam, and then the 31st will be your final exam. And you'll take that with me in here. Okay? So that's our rest of the semester. Now, I also pulled up what we have left to cover for the rest of the semester. So we've already done chapters 1 through 4. I've done 5.1 and almost finished 5.2. So we have 6 sections of chapter 5 and a couple of sections of chapter 6 before the next test. And y'all, we have 3 full class periods before the break. So we may finish this before the break, and it may be after the break. We'll have to see how much we finish today. So that's what we're looking at as to when our next test is. And then you have 4 sections for test 3. And remember, 9 and 10, we don't do a test on. 9 and 10, you'll just have homework on. And then the final exam is going to be on all 10 chapters. So you have 2 more tests and a final exam. Okay? Now, as far as the test that's open right now, remember that test closes today. Exactly half of you have taken it. 7 have taken it, 8 have left to take it. We've got some scaredy cats out there. Which is fine because it's your first test and you don't know what to expect. The average right now is like an 80.5. So we're still at a B, okay? 80.5, that's where the test is right now. So it closes today at hub closing time, which is 8:30, and you must start the test before they close, an hour before they close. All right, questions so far? We good? All right. Now, when we left, we were talking in 5.2. We only had a little bit left in 5.2. 5.2 was talking about probability, and I had 2 problems left in probability, and they were kind of different from the rest, and I said I'll just wait and we'll talk about these next time because they were a little bit different. They gave you these tables, and I want to make sure that you realize that sometimes they'll give you the total and sometimes they won't. So sometimes it'll look just like this. It'll just be the data. And sometimes they'll be nice and they'll say, let me add those up and give you the total. Let me add those up and give you the total. Let me add those up and give you the total. So I don't want those outside edges to confuse you because all they really did, this right here is really all you need. This is your table. This is all you need. It says the following data is speeding tickets over the past year based on male and female. So, so 97 females got 0 tickets. 71 females got 0 tickets. 3 females got 2 tickets. 1 male got 2 tickets. 3 males got 3 tickets. Y'all with me? We good? So this is really just my data. They were being nice and they said, okay, if I want to know how many total people got 1 ticket, they added those up and are telling me that 21 people got 1 ticket. If I want to know how many total females there are, there's 115 females. If I want to add the males and the females, there's 197 males and females. So this dark columns and rows are just adding up those columns and those rows. Yay?
I did have a problem with one of those chart ones. It wasn't that one. That one I felt like was pretty easy, but when it came to the one about cigar smoking.
Okay, we'll look at that one. Let's do these two and then we'll look at that one.
Okay.
All right, this first one says find the probability, and last time, this is a good review of what we did last time. Probability, remember I said, is what makes me happy over total. Find the probability of a randomly selected driver is a female. So what word makes me happy? Females. So I want to know female over total. How many totals are there?
What are you talking about? Oh,
There's 197 total. And how many of those totals are female? 115. So if I said, what's the probability that I'll reach in and pick a driver and they're a girl? There's 115 girls in the pot, and there's 197 in the room. Y'all with me? And then I would take that fraction and turn it either into a decimal, a fraction, or a percent according to what my math lab wanted. Yay? All right. Determine the probability that a randomly selected driver has been issued one ticket in the past year. So what is my making me happy? One ticket. And we're going to put that over total. So what's making me happy is a one ticket. So what's going to be on the top?
21.
21. And what is my total? 197. And then once I get that, I'm either going to turn it into a fraction, a decimal, or a percentage. Determine the probability of a random selected driver is female and has been issued a ticket in the past. Now, this is when we talked about I want a husband that's rich and tall versus rich or tall. If it has the word and, remember I said if I want to make Josh and Madison happy, and means it has to be in both of the list. So if I want to make Josh and Madison happy, it has to be in both of their lists. It has to be in Josh's and Madison's to make them both happy. So for this one, what I do is I look at female. I look at one ticket. And means it's in both lists. So what number is in both lists? 14. That is going to be my and. So it would be 14 over what?
197.
197. That's my total. What makes me happy is going to be my and, which is the overlap, over the total. Now, another way that you could do it is the formula that we use that says take your females, plus your males, and subtract the double dip. So that's another way you could do it. So how many females do we have? 115. How many males do we have? I mean, not males. It was supposed to be females and one ticket. How many males do we have? One tickets do we have?
21.
21. Oh, we're not going to do, that's not going to work for that one. Crap. Because it's an and, it's not an or. This one's just got to be the overlap. It's got to be the 14. Move that one up. That one's got to be the overlap only because it's an and. It's got to make Josh and Madison happy. It's got to be the overlap. Now, the next one is going to be an or. I'm happy if, yes,
If the question is asking for, why for female with one ticket, why are we not just looking at the female?
it said, it didn't say, and we're gonna be talking about this in just, like in the next section, it didn't say, they have to be a female with one ticket. It said, what's the probability that I walk into the room and I pick a female that has one ticket? So I could be choosing a female or I could be choosing from a male. So I'm picking from everybody in the room. Now, in the next section, I'm gonna ask a question that may say, what's the probability that somebody has one ticket given that they're a female? So in that case, I would only be looking at the females. But in this problem, it says, I'm randomly selecting a driver, meaning I'm walking into the whole room, and I want to pick a girl that has one ticket. So I'm still looking in the whole room, which is why my total's still the 197. And y'all, for these problems, you can't wait till the last, and I hope some of y'all learned your lesson, you cannot wait till the last minute to do your homework. You need to do it as you go, and you need to practice. This probability, I can change one word, and it changes the entire problem. Just like this one, I am changing the word to or. Or means any shading. So if I want to make Josh happy or Madison happy, that means it can be anything in Josh's list, or it could be anything in Madison's list. So for this one, the driver is female. The driver has been issued one ticket. So, because it's an or, this would make me happy. 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 So anything that's shaded could make me happy. I'd be happy if they're a girl. I'd be happy if they have one ticket. I'd be happy if they're tall. I'd be happy if they're rich. If they're tall and rich, I hit the jackpot. You with me? So anything that, now here's what's going to get you in trouble. And there's a couple of ways you can do it, and I'll show you the ways. So I would be happy if they're a girl. I would be happy if they have one ticket, but I have to take out the double dip because I don't want to count that twice. And we're going to put all of that over the total. So how many girls make me happy? 115. How many boys make me happy? I'm not boys. One tickets make me happy. 21. But I have to take out the 14. Because when you're counting the 115 is made up of this plus this plus this plus this. And the 21 is made up of this plus this. So you counted that 14 twice. You with me? So when you do the 115 and you do the 21, you counted the 14 twice, so you had to take out the double dip. And what number are we going to put that over? 197. Now, the other way you can do it is say, I don't want to look at those two numbers. I just want to do this plus this plus this plus this plus this, and then you don't have to worry about double dips. Does not matter to me. That's going to give me 122 over 197. All right. I'm going to let you look at one. And then we're going to go to the cigar one.
Oh, I figured out,
What you were doing?
yes, by what you said. It was the same thing.
Oh, okay.
Yeah.
All right. So we're looking at ages and whether they use social media or not. If an adult is randomly selected, what is the probability that he or she uses social media? And you can just write down the fraction. You don't have to reduce it or anything. I know y'all know how to do that. If an adult American is randomly selected, what is the probability that he or she uses social media? Myers has not come in yet. Travis is here. Josh is here. And Barrett is here. And Sharon is here. So we're just missing Myers. So anytime it says probability, that means what makes me happy. What makes me happy over total. It's the probability that he or she uses social media. So probability should be screaming, what makes me happy over total. And this time, what makes me happy is that they use social media. So it's going to be social media over total. So how many social medias do we have? 338. And what is our total? 530. And however Alex wants it, either reduced or in a decimal or in a fraction. The hardest part is figuring out what the fraction is. Yay? All right, here's another one. An adult American is randomly selected. What is the probability he or she is 45 to 54 years of age? Josh, what's making me happy in this one? What am I looking for?
45 to 54.
Okay.
83 over 530.
How many are 45 to 54?
140.
140. That's my 45 to 54. And what is my total?
530.
There you go. There's 140 people ages 45 to 54 out of a total of 530 in the room. So the probability of 45 to 54 age group is 140 over 530, and they'll tell you how many places they want it rounded to. The probability he or she is 35 to 44 social media user. It's got to be a 35 to 44-year-old social media user. Does that help, Travis? what makes me happy, Travis?
Oh, I think I messed something
All right.
up.
From the directions, what am I looking for?
The youth on social media, used by 35 to 45 years.
35 to 45-year-old social media user. So that's what's making me happy. That's what I'm looking for. So in my chart, I need to see what number corresponds to a 35 to 44-year-old social media user. And what number would correspond?
89.
Good. 35 to 44, social media is going to be 89. And my bottom number is total. How many total people are in the room? 530. Cool? This time, what is the probability that he is 35 to 44 or uses social media? So I'm happy if he's 35 to 44 or I'm happy if he uses social media. He doesn't have to be 35 to 44 and use social media. This one has the word or. Okay, so am I going to do where the two overlap, or am I going to do any of the shading?
All the shading. Except for the overlap.
I want to make Josh or Madison happy. So does it have to be in both of their lists, or can it be in either list? Either list. So that means I can choose from this list over here, this list up here, or the combined list. So it's going to be any shading. Anywhere it's shaded, I can use it. So 35 to 44 is here. Uses social media is here. So that means I can pick anything that's shaded. Oops. So, y'all tell me what you want me to write. 125 plus who?
330.
338. So that's the yellow column plus the blue column. Minus 89. So that was the yellow plus the blue minus the double dip. All over 530. So I took all of Madison's list and all of Josh's list, because as long as it's in Madison's list or Josh's list, I'm happy. Now, if it would have said Madison's list and Josh's list, then I can only choose what Madison and Josh have in common, which would have been the 89. Now, if we look over for just a second, we have done 5.1 and 5.2. 5.1 and 5.2. So that was a good chunk of your know the probability, the definition of sample space. That's when we did the roller coasters, Screaming Eagle in this, Screaming Eagle in that. We knew all the Disjoint events, those are the ones that didn't have anything to do with each other. Complement, if I said 20% hit the ball, what percent did not hit the ball? 80%, you do the 1 minus. So we've done, and over here, I'm telling you what problems you need to look at. And I'm being very specific. You only have 3 problems to look at here, 3 problems to look at here, 3 problems to look at here. So I'm very specific in what kind of problems that you need to look at. Now, we're going to do 5.3 next. 5.3 is next.
And it didn't on the test. I do have one question though
Yeah.
about something that was on the 5.2, and it had to do with those, rules and probability.
Yeah.
The number 2 problem on our 5.2 homework,
Okay.
where it's, asking us to like determine the P of F or G, and then do the equation and stuff.
Yep.
I was having like some problems with that.
All
Like,
right.
I don't know what it was, but
All right, let's go to homework. Homework. Let's look at 5.2, number 2.
yes.
All right, let's go. 5.2, number 2. All right, let's pull this up. And I will put it in our 5.2 notes. Paste. How are you doing with me? Okay. List the outcomes in F or G. So I would be happy if it's in F, or I would be happy in it if it's in G. So does it have to be in both? It can be in either. So, where's F and G? Here's F and G. So I would be happy if it's in either one. So I'm going to list anything that's in either one. So it would be 7, 8, 9, 10, 11, 12, 13, 14. So 7, 8, 9, 10, 11, 12, 13, 14. So my answer would be this one, and it would be 7, 8, 9, 10, 11, 12, 13, 14. Now, if the question said F and G, what would my answer be?
It would only be 7 through 14.
F and G, 11 and 12. Because and refers to the overlap, what makes them both happy.
Okay.
Does that help?
No, that's not the hard part. The hard
Okay.
part is when it asked, find P of F or G by counting the number of outcomes
Okay, hold on,
in
let's
F
get
or
to
G.
it.
Okay.
Let's get to this, was 7,
That didn't make
8,
sense in the
9,
next part.
10, 11, 12, 13, 14. Okay? By counting the number of outcomes. So they just want me to count how many outcomes. That's the sample space. How many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8.
So that's our new sample space, and the information in the question is just irrelevant now.
Ooh, hold on. No. This one they want you to, hold on, let me hit check answer. This one they want you to take the, hold on, this one was different.
Yeah.
The sample space of, hold on, this one was kind of crazy. Let me come up here to question help. Let's hit continue. What are we on the second one? All right. So for the example they gave us, F and G, there's 1, 2, 3, 4, 5, 6, 7, 8, like ours was.
Right.
And then they took the 8 and divided it by 12.
Which, I think that's the original
Is that the
sample
original?
size.
Let's go to the original sample. 1, 2, 3, 4, 5,